Okay, before we get started, I would recommend that you go to the video description and grab the URL to the README file that we're looking at, because I typically design these so you can walk through these steps together. So that's my recommendation. So this is deploying simple containers in AWS. This is video 1 of the Simple Container series, and we're going to focus on taking that Python microservice and deploying it with the AWS App Runner. Now, there is also a video out there called AWS Autoscaling, where we deployed Flask microservices using EC2 instances and autoscaling. What we're going to do here is take that exact same microservice from that autoscaling video, build it as a container, and then deploy it with App Runner. So you get pretty much the same thing, but through a different set of cloud technologies. So in this video, what we're doing is we're going to use DynamoDB for the persistent data storage, just like we did in the AWS autoscaling one. We're going to we're going to containerize that application code, that simple microservice, using Docker. Then we're going to push that Docker image into Amazon's Elastic Container Registry. And then finally, we'll deploy an instance of that container using AWS App Runner. So let's talk with what the container solution is inside of AWS, or the container registry solution. Now, they have their own registry service called ECR. Now, these services will work, or this container services will work with App Runner, ECS, and EKS. So this is sort of a baby step onto those new sort of larger scale containerization frameworks. And so, actually, I misspoke. This is the new one. EKS and ECS are actually older. So this is a newer one, but the idea being that once you get into ECR, that you can use those containers in App Runner, ECS, or EKS. Anywhere that Amazon allows you to host containers, you can use ECR. So what we're going to do is we have a pipeline that's going to build that Docker image and then push it into the ECR instance. Then the last part here is we're going to use AWS App Runner, which is a newer way of running containers. It's the simplest way to run containers. You simply say, here's the container, go run it. It handles scaling. If you recall, in the AWS autoscaling example, we had scaling rules associated with CPU load. If it went above 60%, it would add EC2 instances. If it goes below 60% for 5 minutes, it started removing EC2 instances. Here, the system does something similar, but it's by requests. The number of requests to your API will make it scale up or scale down. I think I read somewhere like it's 80 or 100 is the concurrent threshold to add new containers, but it's all handled for you. So, needless to say, App Runner is another serverless options from Amazon, which means you don't manage the servers. The server's there, but you don't manage it. You say, go run this, and it does it for you. So let's go to the diagram. Here's the diagram for what we're going to build. The first part of the build, we are going to build a Elastic Container Registry. Then the second phase, we're going to build the container image and push it into the Elastic Container Registry. Then we will instantiate a App Runner instance on the third part of the build. It will pull that container, and then it will interact with DynamoDB. And of course, we have to have roles for both of these activities. You have to have a role to pull the containers. You have to role to interact with the database. And so at the end, we'll have those 4 HTTP endpoints outputted and available to be used on the public internet. So we've got some prerequisites here. You got to have an AWS account, obviously. You have to have an AWS CLI. You have to have the latest Terraform. I recommend Postman for testing, and then you need Docker for actually running the container images, or building the container images. Now, is this your first time looking at one of our videos? I suggest you go to our AWS and Terraform Easy Setup. It walks you through setting up a very simple project. It just deploys a VM, make sure you know what environment variables to set, all that good stuff. So I'm assuming at this point all that has been set up. So what I'm going to do is I'm going to go to the point where we build the project. So I'm going to copy this right here, go to my Ubuntu development environment, hit paste, Alright, so I'm in the project, and the first thing we want to do is we want to make sure that everything's set up from a runner perspective. So checking VSH is a script we run, and it'll go and make sure you have AWS, make sure you have Docker, make sure you have Terraform, and then it will actually make a connection with those environment variables you've set to make sure that you can connect to Amazon. So that works. So what we're going to do is run apply. Run that. And while it's doing that, I will go back to the documentation and talk about the build process. Now, we kind of went over it when I did a diagram. The first phase is 3 phases to the build. The first phase is we're going to build the ECR instance so we can store Docker images. It's a really quick build, just builds it, puts it in there in your account. And then you need to build a Docker image. We run Docker on the Docker file, and then we push it into the Flask, into the ECR repository. So that's the second phase. The final phase is we're going to glue it all together, and we're going to deploy that App Runner instance that uses the image and also connects to the database. So there's 3 phases: build the ECR instance, build the container, and then deploy the container using App Runner. At the end, there's a validation step where it runs and makes sure everything runs the same, runs correctly on the 4 endpoints. So let's go back to the build, and you can see it's still running, so we will let it finish and come back. Okay, the build has finished. So what we'll do is the validate script ran. We're going to take this URL here, and let's copy it, and then go to the web browser and do a simple smoke test to see if the test endpoint is there, and it's there. So the next thing we'll do is let's go through what actually got built. So I'm in the AWS console, and so what I'll do is go to the Elastic Container Registry section, and you should see that I've got the registry repository I created, and you'll notice the URI, which is actually ends up being a URL on Amazon.com, uses your account ID as your unique identifier. Now, when we get into the other providers, they handle it a little bit differently, but the uniqueness for your repository in AWS is handled by your account ID. And you'll see that in the code where we actually build up where to push. We get the account ID and we use that to form the URI. So there is that. Go into the container, and you've got the Flask app RC1, which is the Docker container we built with the Flask microservices. And this is a private repository. Now, and this is where if you're using this image inside the AWS ecosystem, this is ideal for it. But there's also a notion of creating a public repository. And the use case there is I created these containers, these Docker images, in AWS, or I'm hosting them in AWS, but I'm using them in a different ecosystem. Say, for example, I use them in AKS, the Azure Kubernetes, or the Google Kubernetes environment. I'm not sure why you would do that, but if you were doing a local Docker instance, you could hook it up to this repository and pull the images and not have to be in the AWS ecosystem. So that's it for the repository information. It did run a scanning. It found nothing on there. All 3 of them run scanning to see if you have any vulnerabilities, which can be a little bit annoying sometimes because it's very thorough. But it's good to have that type of scanning running to make sure you're not having some old code that's running that has particularly bad vulnerabilities. So let's go back to the main section of the console, on the home page. And now let's go look at the App Runner instance. So the App Runner instance here, it says it's running. It's that domain that we looked at before, that HTTPS endpoint. And if I click on it, the first thing you'll notice is there's this logs page, which is awesome, because if you ever tried to find logs in Kubernetes without Grafana or some other tool, it's like rooting around in the dumpster. So this is another point of making it simple. There's the actual containerization log, which is here, which will give you errors if it hasn't. But there's also, like, if you want to get a log on your container, like a kubectl logs on the container ID, it's just right there. You just click on it, and you can see exactly this is what your container emitted when it used the startup script that you define. And here it just is starting the Flask services. There's that. Then there is the configuration, and the configuration, it's what image are you using. It's an Amazon ECR. You pick, it's serverless, but you do pick, okay, how many CPUs and memory do you need? I picked the minimum because I'm trying to keep it simple. This is where you define the Flask has an exposed port of 8000, and it'll be routed to 80. And then finally, the auto scaling. I think I talked earlier and I said it was 80 to 100. It looks like the default is now 100. And so this is the default configuration. I think there's more advanced configurations you can put in here, but this essentially says, okay, if one of my microservices is getting more than 100 concurrent connections, let's go ahead and size it up 1 to 25. Again, these are defaults, so perfectly controllable. And then the last section is the health check section, where you're going in and making sure your instance is still running, and it will repair itself. If one of your instances goes bad and stops returning a health check, it will take it out of service and replace it. There's the networking. We're just using the basic public networking. You can connect this to a VPC. Say you wanted these microservices to be available to your own network, but not the public internet, which is most of the use cases that I use in my professional life. Very few things are publicly available. But here it is in the networking section where you can say, okay, use the VPC, and the VPC can be a transit gateway to wherever you need it to be. So this is pretty much it for the configuration. It's simplified containers, so you really just have that container registry with an instance, and then you have this that glues it up and runs it. So with that being said, let's do the last part of the video, which is where we kick the tires on the 4 endpoints that were created. So I'm going to go back into here, and I'm going to say clear, and I'm going to run validate, and I'm going to grab this guy again. I'm going to copy. And once I have it available, I'm going to bring up Postman. I'm going to put that in there. And this is the first endpoint, which is good to go. I'm going to hit send through Postman. The next endpoint is candidates, which should give you just John Smith. That's the second endpoint. The third endpoint is candidate John %20 Smith, and that is the %20 is the space. It's escaping for space, and click on that, and it's going to show you John Smith. And then I can put Mike in here. I change that to a post. This is the fourth endpoint. Hit send. And then if I go back to candidates and I say get, it should show me both. So you can see it's let me maximize that. You can see both here. So that's it for the HTTP endpoints using Postman. This last section, well, first what I'm going to do is I'm going to go to my account, and I'm going to be a good steward of my account, and I am going to delete everything. So I'm going to go in here, and I'm going to say destroy. And so now let's talk about the AWS specific things. We talked about the container registry URI has the account name, and that guarantees uniqueness within the AWS ecosystem. The other cloud providers handle it a little bit differently. In the case of Azure, you have to maintain the uniqueness, so you have to generate a unique code. And then in GCP, the cloud project ID generates uniqueness for the URL. And so you'll see that where we build up the URLs, when we use it, there's a sort of pattern to it, and you create the pattern based on your environment. The second thing is Terraform destroy of the ECR container. You actually have to, and it's right here, if you can't just do a Terraform destroy by default, because it'll say that it has content in it, and it won't allow you to delete it. There's probably a workaround for that, but the other providers don't have that at all. The default delete semantic for the repository works just fine. So that's just a little thing that by default it doesn't clean out correctly. And so if I go look at the repository and look at, I guess it's destroy, you can see the last part. I end up using the AWS CLI to destroy the repository name instead of using Terraform. So those are the two biggest difference in the environments. Beyond that, these runtimes are pretty similar, and the registries are also very similar because they're implementing Docker's API contract for it. Now, one other thing, this is a preview to the next series, in that what we're going to do in the next series is I've created these GitHub actions in this project. So I will walk through setting up these GitHub actions by cloning your own repository, setting the environment variables inside GitHub actions, and at the end of the day, you should be able to, once you've cloned your project, you can go in here and you'll have the 4 scripts that, or 4 workflows or actions that roughly correspond to the shell scripts there. So there's build solution with 3 phases. There is, so if you look at the build solution of 3 phases, you'll see it builds just like we described, but instead of using your environment, it's using the GitHub action environment, which means we have to figure out how to do remote state backends. So stay tuned. There's going to be a follow-up to this video that's just going to be configuring these 4 pipelines and running them, and that will be coming soon.